Yeah, so we continue with the discovery of the nucleus. So, so we discussed the postulates of the Rutherford's atomic model, that is atom. The nucleus is at the center and associated with the positively charged atoms, positively charged particles of the atom. And since the atom is neutral, so there will be equal number of electrons present in the outside the nucleus, which will be revolving out there for a nuclear stability of the atomic model. Now, the drawbacks of the Rutherford's atomic model was that in Rutherford's model of atom, the electrons revolve around the nucleus and the attractive force of the positively charged nucleus would be balanced by the centrifugal force arising due to the rotation of the electron. So, Rutherford said that okay, the nucleus is at the center and there is a force of attraction from the nucleus to the electrons to come close to their nucleus. At the same time, the centrifugal, because they are revolving, the centrifugal force is there, which is preventing it from entering into the nucleus. So, but what will happen is that if this would have to continue longer, then what will happen is this particular particle will slowly and steadily lose its energy a bit due to friction and all, and hence क्योंकि उसका एनर्जी थोड़ा कम होते जाएगा, it will spiral down into the nucleus. So it would happen that न्यूक्लियस यहाँ पे है और इलेक्ट्रॉन्स यहाँ पे है, तो ये इलेक्ट्रॉन्स ऐसे घूम रहे हैं, तो घूमते 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 थोड़े थकेंगे तो अपने आप धीरे धीरे फोर्स ऑफ अट्रैक्शन ऑफ द प्रोटॉन इज नॉट गोइंग टू बी चेंजिंग, सो इट विल कीप ऑन अट्रैक्टिंग इट, एंड दिस बिकॉज इट इज लूजिंग इट्स सेंट्रीफ्यूगल फोर्स, सो इट विल स्पाइरल डाउन एंड फाइनली इट विल एंटर इनटू द न्यूक्लियस. यानी पहले ऐसे जा रहा था, धीरे धीरे पास में आके आते it would enter into this thing. That would have happened if Rutherford's model would have been the right one. So if the electrons move around the nucleus, it must radiate out energy and gradually move towards the nucleus following a spiral path. So it will radiate out some energy because of the motion. It will definitely radiate out some energy and it will spiral down in the path until it collides and ultimately collapses in the nucleus. Thus, Rutherford's model could not explain correctly the stability of an atom. So yes, Rutherford did say that okay, nucleus बीच में है, yes, correct, it's absolutely correct. The electrons जो है वो revolve कर रहे हैं, वो भी correct है. But he could not identify, he could not say that why the electrons are not spiraling into the nucleus even if they are moving continuously around the nucleus. And hence, to answer these questions, Bohr gave his model of atomic structure. So, Bohr's atomic model postulates of Bohr's atomic model: electrons revolve around the nucleus in a fixed orbit. Each orbit is associated with certain amount of energy, hence named energy level. So it was seen that it was not the electrons which had got the energy which was making it revolve around the nucleus, but it was this energy shell. This is this energy shell which is providing the energy to the electrons to move around it, and hence each and every electron is moving in an energy shell. Okay, it's moving in a it's moving in a fixed orbit, and each orbit is associated with certain amount of energy. Hence, it is called as energy levels. The integer n represents the various energy levels. So 1, 2, 3, starting from the innermost, the levels are also designated as K, L, M, N. So from the first part, that is 1, 2, 3, 4, etc., the energy levels were given, with 1 being very close to the nucleus, 2 being far, and these were also given the name of. So this was not only 1, but is also given as K, or 2, or L, and 3, and M, and 4 is N, so on. So that's why the names of the orbits were given as K, L, M, N, or shell 1, shell 2, orbit 1, 2, 3, 4. As long as the electron rotates in one energy level, it neither loses or absorbs energy. When the energy is supplied initially to the atoms, an electron moves to an orbit of higher energy. When this energy drops back to the original orbit, energy is radiated by the atom. So you can see that it was given that when a particular energy is given to an atom, the electrons may move from one energy level to another energy level, absorbing the heat, or it may also happen that it may move from one energy level to another energy level by giving out the heat. So there will be amount of heat or energy which will be absorbed or released. So that's why this, when energy is supplied initially to an atom, an electron moves to an orbit of higher energy. When this electron drops back to the original orbit, energy is radiated out by the atom. So if energy is given to the atom, the electron moves to a higher orbit. When energy is taken out, it moves back to its original orbit. Accordingly, the equation E2 minus E1 is equals to H gamma. Anyways, not so important. E1, E2 are the energy state of the electrons in higher and lower orbits. So that's just telling us that the difference in the energy level is nothing but the heat which is going to be supplied. So if heat supplied is there, then it goes from energy level 2 to energy level 1. If the heat is removed, it goes from energy 1 to energy 2. So that's why so Bohr's model gave the preciseness of location and mode of rotation of electrons around the nucleus. So it was Bohr's atomic model which gave the exact location and the precision with which preciseness of where exactly the electrons are revolving around the nucleus. So that was the atomic structure, so which was given by Bohr. Okay. Now the next thing was the discovery of the neutrons. So now we already had the proton, we had the electrons, we know the nucleus and everything. It so happened that they knew that the mass of helium was 4, which means there should have been 4 protons in the helium atom. Because if the helium atom का mass अगर 4 grams है, 4 units है, और उसका अगर उसके पास we know they knew that there were only 2 protons, then how come the mass is 4? That means there has to be some another thing present in the nucleus which has got mass but it has no charge, and hence we are unable to identify that particular substance by charge. So this gave rise to the thought that there should be some particle in the nucleus which does not have any charge, but it is neutral in charge, but it has got mass equal to the mass of the protons, and thus the discovery of neutrons. So James Chadwick in 1932, he established that an atom consists of subatomic particles, electrons and protons. Electrons have negligible mass, hence the mass of the atom is concentrated in the nucleus. Therefore, the atomic mass should be equal to the number of protons. So, you know that, okay, fine. If the mass or the complete mass of the atom is based on the mass of the protons, because the mass of electrons are negligible, so in that case, the complete mass of the atom will be dependent on the mass of the nucleus. Nucleus में क्या है? सिर्फ protons है, तो automatically mass of the atom should be equal to the mass of the number of protons in it. So, however, in the case of helium, there are 2 protons in the nucleus. Hence, atomic mass should be equal to twice the mass of the proton, that is 2 into 1.08. But its atomic mass is calculated experimentally and found to be 4.003 AMU, atomic mass unit. So, जो 2 होना चाहिए था, उसके पहले 4 है. So, conclusion is that it is therefore proved that in the nucleus of the atom are present particles which possess no charge but have the mass almost equal to that of the protons. This confirmed the existence of neutrons, found to be as heavy as proton. Protons and neutrons are together known as nucleons. So that's why we had that inside this thing there were the protons and neutrons, and these protons and neutrons, because they are present in the nucleus, hence they are called as nucleons. So nucleons are the particles present in the nucleus, that is protons and neutrons. Mass of the neutron, of course, it will be the same, almost the same as the mass of the proton, that is 1.676 into 10 to minus 24 grams. And charge is carry no charge, no electric charge, and are neutral. So that was the discovery of the neutrons. So accordingly, we see that the atom is made up of 3 particles, that is protons, electrons and neutrons. Protons and neutrons are present in the nucleus of the atom, which is present in the center. The mass of the atom is nothing but the mass of the protons and the neutrons, and the electrons are present in the shells, which are energy levels around the nucleus, and the electrons are revolving in that particular energy levels. So this is the main structural difference over here. So now let's see the representation of atomic numbers and the atomic mass numbers. So how do we get the atomic numbers and the atomic mass numbers? Okay, so first is we will define the atom and the molecule. An atom is the smallest particle of an element which can take part in a chemical reaction and is considered the basic unit of matter. For example, OCl are atoms. So atom is that particular smallest particle of element which is going to take part in a chemical reaction, and hence it can be considered to be the basic unit of matter. So oxygen atom, chlorine atoms, they are the examples of atoms of any element. Second are elements. So an element is a pure substance made up of one kind of atoms having the same atomic number and which cannot be broken down into two or more substances by any physical or chemical means. So elements are basically those particular combinations of atoms which cannot be broken down into two or more different substances by physical or chemical means. So they are the one which are in one kind of atom. Only one kind of atom is present in it, and same atomic means जो भी atoms उसके अंदर है, they have got the same atomic numbers and they cannot be broken down. The atom consists of subatomic particles, protons, electrons and neutrons. The three subatomic particles which are of great importance in the understanding of the structure and behavior of the atom are protons, electrons and neutrons. The nucleus, that is the protons and the neutrons, are found in the center of the nucleus of the atom. The orbits, the electrons revolve around the nucleus along imaginary path known as shells and are more accurately orbits or orbit. Okay, so the nucleus contains the protons and the neutrons, and the electrons are revolving in the orbits or shells. So accordingly we see over here that the proton are, we can say now, the protons are given as P with one mass and one charge. Okay, so the charge is 1 plus and the mass is 1. Now electrons, the electrons are given as E, this over here, the mass is 0 and the charge is -1, the charge is -1, this is negligible. Okay. The next is the neutron. So the neutron has the mass equal to 1 but charge is 0. So charge is 0, mass is equal to 1. Where are they present? So they are present in this way. The nucleus contains the protons and the neutrons, and the electrons are present in energy shells or orbits which are given over here like this. So these are the electrons. The circles which I am mentioning over here are the electrons, and they are going to be in this particular form. So this is a typical example of a particular atomic structure where the nucleus is the center which contains the protons and neutrons, and the electrons are revolving in energy shells of the atom. So first thing what we are going to have is the atomic number. So we have atomic number is given as Z, and that is equal to the number of protons or equal to the number of electrons. So the atomic number is the number of protons or the number of electrons present in an atom. Okay, So because we know that the number of protons and number of electrons are the same, that's why we are taking that Z is equals to P or is equals to E. So an atom of each element has its own characteristic number which distinguishes it from another atom of another element. So it has got its own number which is distinguishing it from the other elements. Elements are arranged in the basis of numbers of protons in their respective atoms. This number is called the atomic number of the element and is denoted by Z. The atomic number is equal to the number of protons in the atom of an element. Since the neutral atom of an element have the same number of electrons and protons, the atomic number is also equal to the number of electrons in the atom of an element. Further, the number of protons determine the positive charge of the nucleus in the atom, and the value of the nuclear charge is equal to the atomic number of the element. So, what are the things we can know from the atomic number? First, the atomic number tells me the number of protons present in the nucleus of the atom. Secondly, it tells me the number of electrons which are present in the atom. Thirdly, it can also tell me that what is the positive charge present in the nucleus or what is the negative charge present in the orbit. Okay, so it tells me the atomic number of an element or protons is in the nucleus of the atom, or electrons in the complete atom, or positive charges in the nucleus of the atom. So the positive charge in the nucleus, we will not take this thing, we will take the, so the atomic number can be equal to the protons in the nucleus, the electrons in the orbit, or the positive charge present in the nucleus. So a positive charge in the nucleus is nothing but the number of protons. So accordingly, the atomic number can give you these three things, or you can find out the atomic number by these three things: the number of protons, the number of electrons in the orbits, or the number of positive charge present in the nucleus. The next is mass number. So the mass number over here is given as the letter A. So the mass number, because the mass was the first thing what they discovered, so that was the mass number, that's why A, and this is Z. Now mass number is the mass of the nucleus. So obviously it is nothing but the number of protons plus number of neutrons present in the nucleus. So the mass number of atom is the total number of protons and electrons collectively called nucleons in the nucleus of the atom. The mass number, however, is a whole number approximation of the mass number in atomic mass units. So whenever we are talking the masses, we are going to take it as whole numbers in AMU, so atomic mass units. Since the mass of the proton as well as the mass of neutron is approximately equal to 1 AMU and the mass of neutron is negligible, hence the mass number is slightly less than the actual atomic mass. So you can see that if you talk about the mass, so mass of the atom is the mass of the proton, mass of the neutron, and mass of the electrons. We know that the mass of the proton and neutron is almost the same, and mass of the electron is negligible. क्योंकि उसको हम लोग negligible गिनते हैं, इसीलिए the mass of the atom and the atomic mass is almost the same. Okay, or you can say that the atomic mass number is slightly less than the actual atomic mass of that particular atom, because जो neutrons, electrons को हम लोग जो negligible लिया है, that actually is a part and parcel of the atomic mass. But mass number के time पे we are not considering that the number of electrons present in it, and hence we consider that the mass number is slightly less than the actual mass of the atom. Hence the mass number of element is total number of protons and neutrons in the atom of element. The atomic structure of element deduced from its atomic number and mass number. So now, because of these two things, that is the A and Z and A, these two things can easily tell me, if I know the A and Z of any particular kind of an atom, I can find out that what is the number of protons, what is the number of neutrons, and what is the number of electrons present in that particular atom. So we can easily deduce the atomic structure of an element if I know the atomic number and the atomic mass number. So let's see what happens over here. So if I see that suppose the atomic mass number is, let's say, 23 and the atomic number is 11. So I know that Z is equals to P is equals to E. That means there will be 11 protons and 11 electrons in it. And you know N over here. So if you see the N over here, so here I know that this is 23 is equals to 11 plus N. So what will be N? N will be 23 minus 11. So that will be 12. So in this way, I can find out that what are the number of protons, electrons and neutrons present in an atom if I know the atomic number and the atomic mass number of that element. So always it will be given, any particular atom which is always given by the form as X. A will be at the top and Z will be at the bottom. So A will be superscript and Z will be subscript. Okay, so जो हम square वगैरह लिखते हैं that is superscript, and अगर जो हम लोग chemical equation में O2 वगैरह लिखते हैं तो नीचे जो 2 लिखते हैं that is called as the subscript. So superscript is A, subscript is Z. A is the atomic mass number, which is the bigger number. So bigger number comes up, smaller comes down. So we know here that if A is the atomic mass number and Z is the atomic number, then atomic number Z is equals to number of protons equal to number of electrons. So Z is equals to P is equals to E, and mass number A is equals to N plus P. Therefore, if P is already known, then automatically I know N will be A minus Z. So accordingly, conclusion is that Z is equals to P is equals to E, A is equals to N plus P, or N is equals to A minus Z. So if the example over here is 19x9, so the example over here is 19x9, then I know that the number of protons are 9, electrons are 9, this is 19 minus 9, so it's 10. So that is the number of neutrons are 10 and the number of electrons and protons will be 9 each. The next what we see is how the electrons are arranged in the atomic structure. So we came to know that electrons are there in energy levels, but how much in the energy level, what is the capacity of that energy level, how they are placed, that is what we are going to see in the next part of electrons. So we have got this particular part now. So this is what we know. Now we know that the electrons. So electrons are there in energy levels, that is K, L, M, N, which is given by N. Here N is equals to 1, N is equals to 1. Here N is equals to 2. N is equals to 3, N is equals to 4. Now, it is seen that electrons are present outside the nucleus and revolve around it. Shells and energy levels. Electrons revolve around the nucleus in definite orbit called shells. The centrifugal force prevents them from falling into the nucleus. The shells are also called energy levels, since while revolving in a shell, an electron possesses a certain amount of energy, because when it is in a particular shell, it is going to have a particular amount of energy, hence they are called as energy levels. Instead of shells, they can also be called as energy levels. The shell closest to the nucleus is called as the K shell, first shell or the number 1 shell. The next shell is the L shell, second shell or the number 2 shell. Following shells are M, N, etc. So these are the shells. If we talk about the shells, they are like this. This is K shell, this is L, this is M, this is N. Okay, that is the K shell, L shell, M shell and N shell. An electron has minimum energy in the first or K shell, and the energy increases in order K, L, M, N. So the energy what the electrons will be possessing will be dependent on the energy level. So in K, the energy is the least. L, थोड़ा ज़्यादा, m थोड़ा और ज़्यादा, n में सबसे ज़्यादा. So accordingly m and n, so it will go upon increasing. So there would be at least 7 shells in the known elements up till now. So accordingly you can see that the energy will keep on increasing. So the energy will be on an increasing order as it is going away from the nucleus. And now comes the distribution of the electrons, that is the electronic configuration. So now, how are these electrons going to be placed inside the energy shells? Now that is the main thing. And the electrons are distributed in the shell or fixed orbit. Electronic configuration refers to the distribution of electrons in different shells. Each shell has a limited capacity to hold electrons, and each electron tries to occupy a shell which has the minimum energy. So first of all, what will happen is that electrons are going to be filled up in the least energy shell. Okay, so electrons पहले K में भरेंगे, उसके बाद L में भरेंगे, फिर M में भरेंगे, फिर N में भरेंगे. So electrons are going to occupy the seat in the lowest energy level first, and then it will keep on increasing in the increasing order of the energy level. So that is the main thing, that the minimum energy will be filled up first. The problem of distribution of electrons in various shells was solved by Bohr and Bury, and gives the distribution of electrons in various shells. So this is how the distribution will be taking place. The distribution is not directly. It is something like अगर मैं थिएटर में जाऊँगा तो if the theater is such that the आगे के रो थोड़े कम हैं, फिर बड़े, फिर ज़्यादा, फिर ज़्यादा, फिर ज़्यादा, ऐसे करके अगर tapered form में अगर है तो you know that the आगे के seats कम होते हैं, फिर उसके बाद थोड़े और ज़्यादा, फिर थोड़े और ज़्यादा, फिर थोड़े और ज़्यादा. Similarly over here, the one which are very close to the nucleus will be of a smaller radius, and due to that, the number of seats available in the first shell will be limited. The next one will be slightly more, the next one will be or something more, and then something more. This particular number of seats available in the shells is given by the formula 2n square. So according to this, n is over here is 1, so it will be 2. So that means K can have only 2 electrons, 1 here and 1 here. Only 2 electrons can be there. Of course, not this and this location, it can be this and next to it also. But the main thing is that the number of electrons which a K shell can possess or it can accommodate is only 2 of them. This will be 2 into 2 square, so it will be 8. This will be 18. And this will be 32. So according, because it's 2 square into 2 is 4 into 2 8. This 3 square 9 into 2 is 18. This 16 into 2 is 32. So in this way, this is going to keep on increasing. So this is how the number of electrons which can be accommodated in a particular shell is determined by the formula 2n square. So rule 1 is the maximum number of electrons in each shell of the atom. The maximum number of electrons which can be present in any shell of an atom is given by or represented by the formula 2n square, when n is equal to the number of shells as counted from the nucleus. So K will be having 2, L 8, M 18 and N 32. The second rule is the electrons in the outermost shell. The second rule is that the outermost shell के लिए एक rule है. What is the rule? That is called as the Duplet or Octate rule. Okay, it's a Duplet or Octate rule. So what does it say? That if it is only one shell, if it is having only one shell, then the maximum number of electrons which can be present in the thing is only 2. But if it is any other shell other than the first shell, the maximum number of electrons it can be having is 8 electrons. You cannot accommodate more than 8 electrons in the outermost shell of any atom. An outermost shell of an atom, outermost shell of the atom, even if the capacity, like for example in this case, we have taken this case, we have taken the 2 in the first one, 8 in the second one, क्योंकि 8 तक भर गया, उसके बाद 8 ही रखा था मैंने. The total number of electrons were 10, but I put only 8 in the outermost, and then for another 2 I had to take another shell. Why? Because I cannot, if that would have been the condition, my M shell would have accommodated 10 electrons. No doubt, capacity to 18 का है, but I cannot put 10 because it would be the last shell. Because it is a last shell, it cannot have more than 8 electrons. So because it cannot have more than electrons, I have to take one more shell and put the balance 2 10 minus 2, 8. So 8 rakhe, balance 2 in the n orbit. So the outermost shell cannot have more than 8 electrons. The penultimate shell, last but one, cannot have more than 18 electrons. So that was the octet rule. And second last, so second last cannot have more than 18 electrons. So this is something which is very important. This is called as the octet and the duplet rule. So that is the last one cannot have more than 8 electrons, and the second last, the penultimate shell, cannot have more than 18 electrons. So example is given over here for calcium. This is exactly what I have drawn. This is for 20 electrons. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see over here the protons are 20. So 20 protons here, and electrons are going to be 20. And so electronic configuration will be 2 in the first orbit, second orbit may 8 electrons, third orbit may 8 electrons, and 2 electrons in the last orbit. So this is called as the electronic configuration. So we can see that according to the first law, it would have been 2, 8, 10. If I had just seen this law, it would have been 2, 8, 2, 8 and 10. But because of this rule, I cannot take 10 over here. I have to take 8 and 2 because of the second law. So as per the second law, outermost shell cannot be having more than 8 electrons. Hence, electronic configuration is 2, 8, 8, 2. Okay. So this is the about the structure of the calcium, and also how the structure is differentiated. Now we are going to go through certain different representation of the elements, but in the next video.